Hi class, this is section 11.6. Today we're going to look at graphing our quadratic equations, and I have quite a bit of information up here already for you. So you might want to choose to pause the video before we get started and kind of make some notes to yourself. I'm going to walk through the screen here. Also on page 735 of your book, you might want to choose to look at that or have that open as well at the desk as you're viewing this video. They do a really nice job with some detail that I can't quite possibly do on my chalkboard here because they're able to use actual grid graph paper. The third thing you might choose to do is if you have a home printer or if you have graph paper at home, as if you're working the examples out with me and pausing and kind of trying things on your own, you might want to try your own graph paper as well, and that way you can have some accuracy to your work. All right, so graphing quadratics, like any new skill, it will get easier. So this first initial example might seem a little complicated, but we'll work through enough that hopefully by the end of this video, it will seem more natural. All right, so all quadratic equations have a graph known as a parabola. The parabola can look a lot of different ways, but in general, it's this U kind of shape. Your U can be skinny, your U can be wide, your U can be upside down, your U doesn't have to be, your parabola does not have to be centered right here at the origin. So we're going to look at problems where we take this, shift it left and right, shift it over here, flip it upside down. And some of these numbers down here that I'm going to go through, or these variables, will tell us where to go with this parabola. All right, the basics are outlined right up here. So in this case, this point right here is called a minimum value. If your graph is reflected and it looks like this would be your maximum value. But in both cases, that point in which it shifts, so here it's going up and then it starts to come down. Here it's going down. This is the very lowest point, which is why it's called a minimum value, and then it starts to go back up again. That point is known as the vertex. Your graph also has symmetry. So the line that goes straight through, it's a vertical line that goes straight through that vertex, is called your axis of symmetry, because what we don't have is a situation where maybe it's wide on one side and then skinny on the other. All right, it's not like that. It has to have the same width on both sides of this middle line. All right, so then that leads me to my blue chalk here, where if I have a point on my parabola on the right, then I'm going to have a matching point on the left-hand side of this axis of symmetry, and these two distances are going to be the same distance apart. And so when I get down here and I'm actually going through these steps, that part there refers to the part where it says find the symmetrical point. It's way down at the bottom. All right, so here are the basics. And now I'm going to start building off of what we call the vertex form of the parabola. So my first example looks like this. F of x equals x minus 3 squared plus 2. And my goals for section 11.6 are to state the vertex, to graph it, and to state the axis of symmetry. So we have 3 pieces to our problem. All right. Let's take a glance at my notes here in purple. This is the vertex form of your parabola. If A is positive, your parabola opens up, meaning it opens like this. If A is negative, it means your parabola is going to open down. It's going to be reflected. If A is a fraction, 1/2, 1/3, some number between 0 and 1, your parabola is going to be wider. If A is a number larger than 1, your graph is going to be more narrow, and the bigger the number, the more narrow the parabola becomes. Okay? The vertex itself can be found by looking at this number and this number. So notice that my formula has a built-in negative. So you're going to do the opposite of this, but this back number is going to stay the same. And whatever that letter is going to be that symmetry line that's going to split that parabola straight down the middle. All right, so I'm going to do more than one. So if you get lost on this first example, keep watching because I have multiple examples to go through. All right, so we're going to do opposite. The first thing we're going to do is find the vertex. It's going to be the opposite of that sign, but that sign right there is going to stay the same. So my vertex is going to be at +3, +2. The next thing I'm going to state is the axis of symmetry. If you have a vertical line, it's always an x equals a number. Whatever that number is, just plops right there. X equals 3. So let's draw my graph. Hopefully you're using graph paper. There's the point 3, 2. I would lightly sketch, because this isn't really part of the graph, you're just using it as a guideline, kind of like in an art class, how you would do such a thing. So maybe in a different color, or just lightly sketch a vertical line through that x equals 3. All right, then my instructions. I'm now down here on the green. All right, so it says graph the vertex. Then it says choose an x value and plug it in to find y. So we need to look back up here at my original equation, and we get to pick any x we want. X equals 0 is sometimes a great choice, but not always, because you want to be able to make sure that it's within your scope of graphing. You don't want to end up in a situation where you have to graph up, say, 25 spaces. So in this case, if I plug in x, I get to pick whatever point I want. If I plug in x equals 0, 0 minus 3 is -3, squared is 9, plus 2 more is 11. I can certainly go up 11 if I want to. If your graph that you're using goes up 11, let's maybe try x equals 1. If I plug in x equals 1 right here, I'm going to get a little bit smaller of a y value that's going to be a little bit easier to graph. So 1 take away 3 is -2. -2 squared is 4. 4 plus 2 is, I already wrote the answer there, 4 plus 2 is 6. So 1, 6 is on my graph. So I'm going to graph that next. 1, 6. 3, 4, 5, 6. Right 1, up 6. So that point right there is a point on my graph. All right. If you want to cross that out because we didn't use that, that's fine. If you did use that, you can just modify what we're doing here to match. All right, so way down here, it says lightly sketch the axis of symmetry. We already did that part. And then it says find the symmetrical point to this. I would count this. This is 2 spaces to the left. Therefore, there must be a matching point 2 spaces to the right. And that's what I mean by find the symmetrical point. And so it has to be the same width here. And then the very last step, it's not a dot to dot. All right, you want it to look like that nice, smooth, curved shape. You want to make sure that you have arrows and it continues beyond those 2 pieces. We never just want to have a graph be like that big. Let me try that again. Like that big and that's it. It goes continually. It's going to continue to get slightly wider depending on that number. All right. We're going to do it all again. Different numbers. My next example is f of x equals 2 x plus 1 squared plus 4. All right, so I put a number in front of the parenthesis in front of the squared term. This is that a value. This is positive still, so we can anticipate my parabola opening up. It is a number bigger than 1, so it's going to be slightly more narrow than my last example. That's just more of a guideline than something you need to memorize. Again, I would refer to page 735 if you want some nicer examples that the book can show you. All right, step 1. My vertex, opposite, same. Opposite, same. So my vertex is going to be at -1, 4. And that axis of symmetry is going to be the line x equals -1. So that just plops right there. All right. So -1, 4 is right there. I'm going to lightly sketch my axis of symmetry. And I get to pick an x. This is sometimes the hardest part for students because they don't like, what x should I pick? All right. So I'm going to pick an x. In this case, I think 0 is going to work out great. Because if I choose x equals 0, 0 plus 1 is 1. Squared is still 1. Multiply it by 2 is 2. And add 4 more, and I get 6. So 0, 6 is a point on this parabola. So not going to go left or right any, I'm just going to go straight up 6. So there's the point 0, 6. This looks like it's only one space to the right. So if this is my axis of symmetry, I'm going to go exactly one space to the left. And I'm going to put my symmetry point right there. And now I'm going to smoothly draw that curve, remembering to extend that past those points and add in arrows. That's it. Hopefully this one was a little bit easier. My next example, I threw in a negative for the a value, so you have one example of how this is going to look if it's going upside down. So negative x plus 2 squared minus 3. And again, all the ones that have fractions or really strange fractions, we're not going to look at. This is just hitting the highlights of how to graph a parabola because of all of our circumstances. All right, so that's negative. That just tells you it opens down, so we should anticipate it to go like that. So you know that if you do all your work and it's going up, then you've done something wrong because that guarantees it's going to open down. All right, your vertex is at -2, opposite, and then the back number's a -3, so it stays the same. That axis of symmetry is going to be x equals -2. My next step is to sketch out my graph. So -2. -3, there's my vertex. There's my axis of symmetry. If I choose an x value and it ends up here, then you know I've done something wrong because this is my max value. So since it goes upside down, this one has a max. The vertex is also a maximum. All right, so what x might I choose? 0 would be all right. If I choose x equals 0, 0 plus 2 is 2. Square it to get 4. Make it negative to make it -4. And subtract 3. And so then y would be -7. If you prefer, I'm not writing it in coordinate form, but that's what I'm doing. All right, so 0, -7. So down 1, 2, 3, 4, 5, 6, 7. So there's a point on my graph. It looks like that is 2 spaces away on the left, or on the right, excuse me. So I'm going to have a matching point 2 spaces on the right. And so now I go up to that max value. And I extend that with arrows. and I draw a nice smooth curve. All right, so there's some weird, this is the basics. There's some weird ones. What happens if one of these things isn't there? Because it's 0. I did plan one with a fraction out in front just to give you a glimpse of how it looks like when it's a little bit wider. So we've got a few more to look at, but I'm hoping it's getting easier. So this one I put in a fraction as well as there's no number here in the back. All right, so what number means nothing if there's nothing there? 0. So it's not like you don't have a y-coordinate, but when you see these problems in the book or on the exam or what have you, you go ahead and you add in that 0 because it means we didn't shift that parabola down, up or down any. We just shifted it to the right. So my vertex opposite same, so it's going to be a positive 4, 0. My axis of symmetry is going to be x equals 4. So now I'm going to go right, 1, 2, 3, 4. We should anticipate this opening up. And because it's a fraction between 0 and 1, like I mentioned before, it should turn out to be a little bit wider than the ones we were looking at in the past. We still need to choose a value so that we can find that symmetry. Oh, I need to draw in that symmetry point as well, that line. So there's that. All right. Would 0 make a good choice? I always try 0 first. 0 would make a pretty good choice because I'm going to end up taking half. So make sure you remember your order of operations. We need to square before we do this. So we're going to do the parenthesis first, then square, then divide by 2. All right. So 0 minus 4 is negative 4. Squared is 16. Half of 16 is 8. So if x is 0, my y value is 8. If this comes up on the homework, let's look real quick on what would happen if I would have chosen x equals 1. If I choose x equals 1 here, 1 take away 4 is negative 3, squared is 9, and then when I take half of 9, I end up with a decimal or a fraction. I end up with 4.5, which is way trickier to graph. So I would reinforce the idea that you get to pick what value you plug in here. And if you don't want to deal with a fraction, choose a different one. So in this case, because this is a 2, make sure that that turns out to be a number that's divisible by 2 or an even. If this number here was a 3, make sure that when you do this, you end up with a value that's divisible by 3 and so on, whether it's 4 or 5 or what have you. So you are in control of what number you pick there. All right, so we have 0, 8. All right, and this is, all right, you're going to just have to bear with me because I didn't plan this out and I'm already very far into this video. So this is 4 spaces to the left. So 4 spaces to the right would be 1, 2, 3, 4. So my symmetry point would be about right here. And so it's going to be a little bit wider and it's going to go off my door here. Sorry about that. All right. Last one. Maybe I'll show you one more with the 3 that I was referring to. I didn't write one down, but I'll just make one up real quick and hope for the best. Okay, so f of x equals negative 2x squared. So that tells us right there it's going to open down and be narrow. So negative 2x squared minus 1. What's different about this question? There's no parenthesis piece. So there's no h. So h must be 0. So if you choose to, so that it matches this form, rewrite it with a 0 as a placeholder. So negative 2 parentheses x minus 0 squared minus 1. And now literally everything works the same. Your vertex is at 0, -1. Your axis of symmetry is going to be x equals 0. There's my graph. We're just going to go down 1. It's not going to open up, it's going to open down. My axis of symmetry is this y-axis here. It's possible I referred to that as my x-axis earlier in the video. All right, x and y. All right, and now I need to choose a different point. Now, if I choose x equals 0, that's already taken. So try 1, try -1, try 2. You get to kind of mess around and pick any other x value. So if I put in a 1 right here, and x equals 1, 1 minus 0 is 1, squared is 1, times -2 is -2, take away 1 more is y equals -3. So the point 1, -3 is on my graph, so it's right here. This is one space to the right, so I have a matching point one space to the left. This should look a little more narrow to you compared to the ones we did previously. Not my best graph, but I've been doing pretty good so far. All right, let's see if this one doesn't work out. I'm winging it here. But I want to show you just one quick example. So let's do 1/3. Let's do x plus 1. And maybe a -2. All right, squared. So if you haven't been pausing and kind of guessing for yourself or checking your understanding, maybe do that now. Which way is it going to open? Where's the vertex? Where's that axis of symmetry? How much can you do on your own without watching any more of the video? My vertex is going to be at -1, -2. My axis of symmetry is x equals -1. So -1, -2. Here's my axis of symmetry. I need to choose a value so that I know kind of that symmetry point once again. So if I chose 0, I'm going to end up with a fraction. If I choose 1, 1 plus 1 is 2. 2 squared is 4. That's not going to work. So what I want here is something that's divisible by 3. If I choose x equals 2, watch what happens. X equals 2. 2 plus 1 is 3. 3 squared is 9. 9 divided by 3 gives me a nice number. So 9 divided by 3 is 3. Take away 2 is 1. So I know that 2, 1 is on my graph. 2, 1 is right there. That point is 1 to count the spaces. So over 1, 2, 3. So I know there has to be a matching point. 3 spaces the other direction. 1, 2, 3. And go up 1. This one, notice how wide it is. I think I did an okay job with my symmetry. And so this one should look much wider than the problem we just looked at. But that's what I mean by choosing the x that makes this a nice number. All right, practice the homework. This can be super foreign at first, but I think this will give you a good background so that you can be successful on your own. And we practice graphing again when we do 11.7. So this is kind of a one part of 2 parts of graphing. So have a good day, everybody, and I hope to do 11.7 in just a second here. Thanks. Take care.